This week we're going to talk about techniques used by hackers. And you might ask yourself, why would I want to teach techniques used by hackers? The reason is because these are the same techniques that white hackers and ethical hackers would use, but they're also some of the same tools that network administrators use. So, uh, knowing that these are used for good purposes to be able to detect flaws in systems and then be able to respond to them in a proactive way is the reason we teach this. So, what are our objectives? To understand the basic methodology used by hackers, some of the tools, and understanding the hacking mentality. Let's begin. So, reconnaissance is this whole idea of finding out as much as you can about a system. So, for example, anytime if you were to do any kind of report, what you do first is you look at the literature, right, and you look to see what's out there before you start to do your own research. Well, the same is true within hacking. Before you would do any kind of attack, you need to know everything you can about the victim that you're going to attack. You want to know where they might live. You might want to know their email address. You might want to know, what systems are on their network, understanding what their business is. So it's just looking for information, whether it's about an individual, an organization, or a network. The key thing here is reconnaissance is a passive scanning. You're asking another source. You might go to who is in Google. You might ask people who work there, but you're not actually doing it to them. You're asking others and going through third-party sources to get the information. It is a passive type of scanning. Some of the passive techniques we might use is social engineering. You might ask somebody else, go into chat rooms. So for example, it's very common for network administrators to have their own chat rooms where they can say, hey, has anybody had this problem with their Cisco router on port 25? And other people who are on that particular group might answer. It's a good way to get information. I'm sure we've all done it in the past. And another way is to be able to look at a job ad. So, for example, we'll look at some job ads later, and you'll see that the job ad defines what it is they're looking for the company. So that kind of gives you an idea that that's what the company uses. And those are what we call passive techniques. So some information about websites, you could use a tool called Netcraft. And these tools we're going to practice a little later, but this is just an example. You go to news.netcraft.com. Here it is, Netcraft. And it starts to give you some information about a company name, what operating system they use, all types of other information, the DSN, how long it takes, the first byte. Very helpful information as you start to just find out information about a particular organization. Okay. Archive.org shows the number of times something is saved. So, for example, it'll tell you how many times somebody has updated their operating system. This is just another way to see how often an organization is updating, to know what version they might be on, for example. So if you see the last time they updated was on version Windows 10, then you know that they're at the most current version. But if you see Windows 8 and there's nothing else, well, then you would suspect that they might be behind in what their system says. Port scanning is something we have already talked about quite a bit. It's looking to see which ports are open. This is an example of a port scanning, and it uses a tool called Nmap that we're going to discuss. I loaded Nmap onto my Mac, and I first ran into a security problem with it, so I had to actually override my security using the control key and open to get to it. Nmap, I will show you. Nmap, I will show you. Go to my applications. Is actually called Zmap in. Don't follow my password. Should come up. Here it is in my applications, and we're going to get that down. And for example, if I wanted to do a first of all, this tool gives us a lot of information. It lets us scan. It has it does all types of scan. An intense scan. It looks for UDPs. Looks at all the TCP ports. It could ping scan. It could do a lot of things. A trace route. So we want to make sure whatever we would do that we would not do anything very evasive. So I wanted to look at Marymount. So one of the things you can do to find out the Marymount IP address, because it needs an IP address, is we can just quickly say IP address Marymount. And here we go. And here it comes. That's Loyola Marymount. Let's stick with ours. Here, I think this is ours. All right, so we can we'll just take this very first one, 198. It's Glebe Road. I'm going to copy it. I'm going to go to ZenMap here. Where is it? I think it's here. Maybe it's here. Okay, I'm going to just paste it. All right, I'm not going to do an intense scan. I'm just going to do a quick scan for this particular event. So I do a quick scan, and it's going to give me some information. It's going to tell me here are all of the ports. So we know that 25 is for email. We don't see 20 or 21, which is FTP. If we say services, we see all the different services that are running. So we see email as one of them. We see the Cisco router as one of them. I don't know what all these are. For ports, here's all of the ports that they have. We looked at this before. One of them is HTTP, which would be 443. The topography, not really telling us too much. Our host details, it's up. There's 7 filtered ports. There's 93 closed ports. This is our IP address and the scans. So we can find out a lot of information. And if I did other types of actions, different things would happen. If I did a trace route, for example, this actually will take a few seconds, but it looks like it took 12 different hops to get to where we are. And we know that a hop is going from one particular server to another, and it tells us here it went from Washington, D.C. to Verizon, then to it looks like something with GW, went to Ashburn, which is most likely Verizon, Capitol Heights, which is kind of strange. Anyhow, there's quite a bit of things that happened here to get it to our site. But this is using this tool called Nmap. So let's continue on. Current slide. Okay. So Nmap does a whole bunch of things like we just saw. These are the commands that you can use with it. A UDP scan, a skull. One with an A is one that's going to give us lots of different, it kind of packages it together, -A, and I don't see it on this list. But I have enclosed a video that will give you even more information about Nmap because it is a whole class in itself. So we know our scan types. We've already done a ping, a connect, a SYN, and a FIN. So a ping we know is a message type of protocol. A connect goes with a TCP/IP, and we know that a SYN is part of the three-way handshake, and a FIN is also one of those messages that come back with the handshake as well. Remember, we talked about it. There could be many different flags that come back. Okay, so the ping sends a single ICMP echo request from the source, my computer, to the destination. So ping marymount.edu, and it gets a response. If it gets a response, that means that that system is up. If it doesn't, if it's not available, you won't get a response back. A connect scan fully connects to the target in the port. Fully connect does a complete TCP/IP handshake, so that means it's going to have the SYN, the SYN-ACK, and then the ACK. This is most reliable type of scan, but you are sure to be detected. A SYN scan is a little more tricky. So we know that in the three-way handshake, we send a SYN request to the target, and it gathers information about what ports are open without completing the handshake. And when an open port is identified, so it just keeps sending a SYN to each of the ports to find out which one is open. And this technique is also called a half-open scanning. And this prevents the TCP/IP handshake from being finished. So what they do is it sends an RST as opposed to an AC key flag back, RST meaning reset, so that it isn't finished. And a send or a finish looks to see if the port is not listening or no response. If it's listening, an error response is received. So all of these different types of commands sent to the ports will provide different information as to whether it's open, what the purpose of it is, what the IP address is, etc. So enumeration is the next step. So first we have reconnaissance. We do that passive type of approach. Now these that we're doing now are active. We're actually going after this particular network. Enumeration is finding out what's on that system. So there's lots of things that you can use. These are a few of the types of software you can go onto the network and look at. Netcat is a very popular one. Wi-Fi password dump, will dump passwords. But these are what's on that particular network. Cane Enable is a very popular enumeration tool. If you have time, you can go to Cane Enable and look to see how it works. But as you can see here, it'll tell you about the network. It'll tell you exactly what's on it. It's got some cracker passwords, meaning that it will try to utilize some rainbow tables, which are a list of passwords, to crack passwords. Lots of different things on this particular type of tool. And these are out there on the network. You can go to these. So for example, if I go to click Cane Enable, here it is. Cane Enable was released. I could get more information about it. I could actually run it if I wanted to. Lots of different things. So go take a look at this as well. Okay. SQL injection. Briefly, we spoke about this. On a website, it's possible for you to actually inject a virus into that website. And it's most likely happening when you have to access a system. So for example, I'm a member of a group called InfoGuard. So when I go to InfoGuard, I have to put my username and password in there. And with SQL injection, it looks for websites like that where you have to put something in it, and it puts in some code that causes the code to always be true. And if you know SQL, you could know that x equals x in the code will cause the system to say, okay, this is an acceptable answer, and it'll let you into a system. So that's just one way. So SQL injection is one way. In case you don't know what is SQL, it's a relational database. So if you've ever used Access, Access is a relational database. Almost all of the new systems use some type of SQL-based. MySQL is a free by Microsoft SQL database. It contains tables and rows. It uses something called SQL, which is structured query language, English-like words to be able to do computer commands. Select from a table called users where the username is admin, for example. What that would mean is find any username named admin. So more on SQL. You can look at this more in your own time. I don't know why this keeps coming up. So moving along here. Oh, I'm going the wrong way. Okay. So this is how that would work. You would inject something into it where it would be double quotes. This is just informational. I don't expect it. Cross-site scripting, a hacker identifies an area in a website. So for example, have you ever gone to a website where you look at all the things, maybe it's Etsy, and then you're ready to make a payment, and it sends you over to a Foursquare, for example. It might send you to a company called Foursquare, which is able to accept your payment because the website itself doesn't program, but it has a third party do it for it. Well, a hacker identifies an area in a website that's going to do that kind of transition over to a third party. And what it does is it injects its own JavaScript to send the unsuspecting user to the hacker's page. And then the hacker gathers all that information which could be the potential buyer's name, address, and credit card. So this is called cross-site scripting. OCrack is a tool that you can download, and what it is it will take passwords and it will try to crack them. It won't crack passwords 10 characters or more, and it uses something called a rainbow table to do this, and it really looks at producing a text file with usernames and passwords. It boots to Linux, grabs the Windows passwords, because Windows passwords are actually stored in a hashed file, and you can't really crack a hashed file, but what you can do is take that file, that SAM file is what it's called, you copy that SAM file, and then you use cracking tools and hashed values of other passwords to see if any of them match to produce this. Like I say, it won't crack passwords 10 characters or more, so that's why it's so important to have your password be greater than 10 characters. Okay, there is in your book a software to show you how you can actually create your own malware. I'm not going to show you how to do it, but it's out there on the internet, and the point is that it's very easy to create your own viruses. Okay, and I think it's called Terabit Virus Maker. You set a few parameters here, and voila, create the virus. That's something you can do on your own time if you want to. Other attacks are, scripts and pass the hash, which is kind of like a way to crack passwords. So pen testing is looking at a system and seeing how one can get in. And there are specific guidelines for pen testers. And the NIST 800, 815 is one of the first places we're going to go. National Security Agency Information Assessment Methodology, meaning that there's an actual methodology for pen testing. It starts with reconnaissance, then it goes on to actual active testing. So the steps are here: planning, identifying your test conditions; discovery, identify how you will test them; executing your attack, and then writing up your results. And you would never, ever do this without having a contract from an organization or a company and very clear guidelines as to what you would do. So I'll repeat that. You would never do this without a contract, a scope of work, and a clear identification as to who has authorized it. And one thing you might want to have is something called a get out of jail free card, that you have this piece of paper saying you're authorized to do this, that in case you're doing it, for example, on a military facility to test the security of a military facility, you don't get arrested by the military police. So, crypto virology, easy to say, is ransomware. That's one of the things that falls into that. It's browsing the web. It's demanding money. It's an example of taking, and there's different ways that you can do it. One of the favorite ways is that they like to take over like a database or a group of files. They like to then encrypt them, and they tell you that unless you give them money, they're encrypted and you're never going to see that data again. So that's a very, it's dangerous. And that's the end.